Right, so here's another type of simultaneous equations in terms of it's got an extra stage before you can actually solve it. So you still do the same in terms of just label it equation 1 and equation 2. This time we can't do a direct subtraction or multiplication as yet. We actually need to make sure that the letter we want to try and eliminate, that in both equations it might be equal to the same, so the coefficient, which is just the number in front of the letter, is the same, and in this case it's not. Okay, so what we need to think about is how do we get, if we're going to use, I'm going to use y here, so how would I get that up? That's 2y, and that's y, so if I actually times that by 2, what we would end up having now is 2x plus 2y, and that equals 14. So what we can do, right, so this is the new equation 2. So what we can actually now do is actually take this equation away from this equation. So if we actually get equation 1 and subtract equation 2 from it, and what would happen there is it will be 3x minus 2x gives you x. You then have 2y minus 2y, which is nothing, and 16 minus 14, that equals 2. So straight away we've now got x equals 2. What we then do is then pick one of the equations to substitute this value in. So if I have a wee look at equation 2, I say x plus y equals 7. We know that x is 2, so 2 plus y equals 7. If I take 2 from either side, what we'll find is y equals 5. So we've got x equals 2, y equals 5. Now we can rewrite this one, equation 1, and just substitute the values in just to make it sure. So that's x is 2, so it's 3 times 2 plus 2 times 5, and that should equal 16, and surprise surprise it does. So remember, when you work out what x is and what y is, that equals that for both equations. So if we go on to the next one, we then again, it's very similar, just number them, and we want these two coefficients to be the same. So how do we do that? Well, it's obvious, just like the previous one, times that by 2. So what we've now got is we've now got 6x plus 2y equals, and that's 34. Okay, so that's your new equation 2, and again, instead of actually subtracting them, okay, so if it's the same sign, subtract, we're going to add these two together, so we're actually going to get equation 1 and add it to equation 2. So that's these two there, so 4x plus 6x, that's 10x, there's an x there, and that equals 40. Divide that by 10, divide that by 10, and x equals 4. Then what we can do is we can substitute this in. So I'm going to choose equation 2 just to substitute it in. So I'm going to say that's 3x plus y. Oops, 3x plus y, I'll just undo that a wee bit. Scroll that down a wee bit. Equals 17. So that's 3 times 4 plus y equals 17. So that's 12 plus y equals 17. Take 12 away from that side, take it away from that side. So that means y equals 5. And again we can substitute it in, so 4 times x, so that's 16, minus 2 times y, which is 10, so 16 minus 10 does equal 6. Okay, so that's the solution to that one. Right, so this is something similar to the last one. Again, we don't have two equations we can directly add together or subtract just to eliminate one of the terms. What we're going to have to do is look at multiplying, but this time you're actually having to multiply both equations. So we've got equation 1 and equation 2. and you have to think about what terms you want to eliminate. So I'm going to look at just getting rid of the y. Right now, I can't times equation 2 by anything to make it, or anything sensible to make it 3y. So what you actually, the wee trick is, you multiply equation 2 by the coefficient of equation 1. So you look at what you're actually wanting to get rid of. I'm going to get rid of the y's. So equation 1, I'm going to multiply that by 4, and equation 2, I'm going to multiply that by 3. Because if you think about it, we've now got 3 times 4, which is 12, but that's the same as 4 times 3. Okay, so we then need to rewrite this all out. So that's 8x, that's plus 12y equals 44. That gives me now 15x, and that is plus 12y, and that gives me, that will be 72. Okay, so that's equation 1, that's equation 2. I'm going to actually just rewrite these out and flip them round because it's just easier working that way. 8x plus 12y. I mean, I'm putting in a lot of work in here, but you get your marks for this. So we can then subtract these, so we can actually do, can then do equation 2 subtract equation 1. So that's 15 minus 8, that gives us 7x, that is 28, so 7x equals 28. So then want to work out what x, if I keep on forgetting to press that button. So what we do is we divide that by 7, we then divide that side by 7, so that's x, and that equals 4. What we then do is we then have to substitute it in. So what we're going to, I'm just going to pick equation 1. Right, so equation 1, that gave us 3x plus 3y equals 11. Scroll down a wee bit. So we know x is 4, so that is 2 times 4 plus 3y equals 11. Now 2 times 4, so that's 8 plus 3y still equals 11. And we take away 8 from that side. This pen's quite annoying. Take away 8 from that side, subtract 8 from that side. So now we've got 3y equals 3, and last but not least, y therefore equals 1. And then what we can do is we can substitute it back into the equation. So say we use this one, 5 times x, so 5 times 4 is 20, plus 4 times y, which is 4 times 1, and that indeed equals 24. Okay, so that's the last type we'll be doing, and it's the more complex one, but you just have to be multiplying both sides, and then you can just work out your normal way. You're either, if same signs, you're adding; if it was different signs, you'd be subtracting.